We recently saw this picture taken by a Chinese space probe to the far side of the moon that shows the moon and the Earth in the same image. It was on Facebook, and a lot of the comments we read clearly show the people making the comments didn't understand what they were seeing. So we'd like to clear up some of the issues they were having. Here's my globe, 12-inch diameter, and my wooden sphere moon, 3 inches diameter. So these are the correct proportions between the Earth and the moon. But if the space probe was closer to the moon, farther from the Earth, you can clearly see the moon's going to look a lot bigger in the frame. Okay, I'm here out in my backyard to address this issue of the Chinese probe to the moon that took a picture of the moon and the Earth together on its way back. People are saying, oh, the moon and the Earth look like they're the wrong size. The moon should be 1/4 the size of the Earth, which is true. And also they have the question I'm addressing is why you don't see stars. So what I've got here in my backyard is I set up this couple of tables, one with my globe Earth over there, and over here I set up a moon. Set up a moon and the globe Earth. The globe Earth over there is 12 inches diameter. This moon wooden sphere is 3 inches in diameter. So that's the correct proportions between the Earth and the moon. 12 inch to 3 inches about right. And then there are 30 feet apart, or about a little over 9 meters. So that's the correct distance. So if this camera represents my space probe, it's going to be a lot closer to the moon than it was to the Earth when it took the picture. So you'll see the results I got when I took this picture of my wooden sphere moon to my globe Earth over there in scale. I don't know the distance exactly for the space probe, but the idea here is just to show that if the probe's camera was a lot closer to the moon than it was to the Earth, the moon will definitely look bigger than the Earth. That's just perspective, right? Here's the picture of from the Chinese space mission on the right, and my backyard setup on the left. So you get an idea that the moon can be much larger in the frame than the Earth if the space probe or the camera on the space probe is closer to the moon. Again, I'm not showing the actual distance of the probe from the moon because I don't know what that number was, and I'm also not showing what kind of lens it was using. So the idea here is just to see that the closer the probe is to the moon, the bigger it will be in the frame, even much larger than the Earth in the distance. We should also point out that from this perspective, the sun is behind and to the left of the space probe that took this picture. That's why both the moon and the Earth are lit up about the same way. So from the Earth's perspective, this would be around the time of the new moon. The moon would mostly be dark. So there is an expression, dark side of the moon, but it's really just the side of the moon that's facing away from the sun, and the light side is the side facing the sun. So, and that changes on a continuous basis throughout the month. So there is no dark side of the moon that's the same. It's just the far side versus the near side. Here's a quick demonstration. Here's the light side, here's the dark side. This is the sun, let's say. So you can see as the moon goes through its orbit, it'll get darker and lighter depending on where it is in its orbit. So there is no dark side that stays dark. It's the near side to the Earth and the far side from the Earth. That's it. Another issue people were having was why you don't see stars in this image. Of course, it depends on the camera settings. So I'll give you an example of what that will look like. In this image, I used settings that were appropriate for the moon, the wooden sphere moon that was closest to the camera. In this greatly overexposed image, you can clearly see my backyard with fencing and the shrubs around it that we couldn't see in the previous image. The settings on the camera also explains why you don't see stars in the Apollo moon mission images, either from orbit or from the surface of the moon. One of the commenters on the Facebook asked the question, why is this sky or the universe so dark, shouldn't the sun be lighting up everything? It always looks black. Well, that's a misunderstanding of how light works. Light can travel through space, but the camera or your eyes won't pick it up unless it bounces off of something. It has to reflect off and then reach your eyes. So when the sun shines, unless there's a planet or some other celestial object to reflect that light, you're not going to see anything. It's going to look black. So here's a demonstration. I've got this flashlight on. It's very bright, and I'll aim it at the fence. And you can clearly see it's lighting up the scene. Now, I'm going to shine up at the sky, and you'll see the difference. Okay, so now I'm aiming up at the sky. There are some clouds up there, and I can tell with my own eyes that I can see some light from the cities reflecting off the bottom of the clouds, but you really can't see that on the video. I'm aiming the flashlight up, but you can't see that the flashlight's on until I put my hand in the way and reflect some of that light back to the camera lens. So it's aiming at the sky, so is the camera, but you can't see the flashlight until it's reflected. So that's why the sky is black all the time when you look at space pictures. Three issues. One is the size differential between the moon and the Earth. That's pretty easy because of the camera being closer to the moon will look bigger. We also looked at why you can't see stars in the images. It's because the camera is set for the bright lunar surface and can't get stars at the same time. If you set it for the stars, the moon surface would be completely washed out. So cameras can't get both. You have to set it for one or the other. And of course, they chose the surface of the moon as their preferred setting. And then the last one was why the universe looks so dark when the sun is lighting things up. We looked at address that with my flashlight example. The thought I'd like to leave you with is the moon takes a month to go orbit around the Earth once. That's where the word month comes from. But if you could be on the moon long enough, you could actually experience a sunrise, 2 weeks of daytime, a sunset, and then 2 weeks of nighttime. Think about that for a while. If you like this kind of content, be sure to like and subscribe and hit that notification bell for the next time. We'll see you then.